right, so we have a lot to talk about with reference angles and non-acute angles. Highly recommend that you get the free guided notes at divideandconquermath.com for this. So first, I just want to review a few things. So what is a quadrantal angle? So these are angles in standard position whose terminal side lies on the x or y axis. So just to show you, remember with standard position, you start here and then you go this way, well in this case. And so this would be 90 degrees. This would be starting from here. This is a 180 degree angle going all the way around. This would be 270, so on and so forth. And so now I want to ask the question, what is associated with every non-quadrantal angle? A reference angle from standard position. You've actually been doing this, you just didn't know it. So just to kind of remind you and to show you. Okay, so standard position, we start there, we go this way. And so from this situation, we have been creating these right triangles, and you might have been thinking, like, why is this different from the right triangles we were looking at before? So they're really not. This actually just creates a reference angle. So this right here is the reference angle, but we can create this around the entire around the entire graph. So if I come this way, now drawing down this way, this would be my new reference angle. So we still have this right triangle. Or if I go this too. So reference angles, that's basically what we have been creating this entire time with the standard position. And so now we want to think, can I go ahead and use just right triangles? Do I have to keep using standard position? Basically in this lesson we're going to get rid of having to use standard position because we're going to understand reference angles, and we can just always refer to the triangle. So where I want to start, I want to find the reference angle for each angle. So I'm going to show you how to do this. Now, the first thing that you're going to want to do, of course, is you're going to want to draw a reference. So you always want to sketch this. Okay, so cheat sheet for you. We've got, these are where our angles will fall. So we're talking about 274 degrees. So we are going to fall somewhere in here, all right? So I've got my initial position and I swing all the way to somewhere out here, okay? And so then to get to my reference angle, so this is normally how I kind of create my right triangle. And so now it's like, okay, there's the angle, but what is that reference angle? What are we doing with this? And so basically now what we're going to try to do is relate this to the acute triangles that we've been playing with. So this angle in here, this is what we want. So this takes a little bit of finessing, but you're very often going to use this axis to kind of drive how to find that reference angle. So in this quadrant, on this axis, this is 360 degrees. That's kind of the way I think about it. So there's 360. So what I'm going to do is I'm going to take 360 minus 274. And so basically what this means is I could just go ahead and calculate all the trig functions I want for 86 degrees. And I would also know then what it is for 274 degrees. Now, there are a few adjustments that we have to make to this, so this is not perfect, but this kind of gets you to the reference angle idea. So we're just trying to get the idea right now. So 86 degrees was our reference angle. So now let's move on to our 822 degrees. So the first thing that you need here is you need the coterminal angle between 0 and 360 degrees. So anytime you have an angle that is not between 0 and 360 degrees, you always want to do the math to figure out what it is coterminal with. Now, if you forgot what coterminal means, just a really quick reminder. So again, I have some angle here, let's say like 45 degrees. So this is in standard position. So the angle that would be coterminal with it would be found by taking a full rotation. This would be 360 degrees. So basically I make a 360 degree rotation, and 405 is coterminal with 45. So these are what are known as coterminal angles. So going back to our situation, when I want to know what's coterminal with this, I need to subtract off 360 in as many multiples as I need so that I get this to a number between 0 and 360. So in this case, by subtracting off these two factors of, or these two multiples of 360, I get 102 degrees. That's between 0 and 360, so this is the angle that I am interested in. So now I want to treat this 822 degree angle, I want to just treat it like a 102 degree angle. And so once again, now I've got to get to my reference here. So just using my little cheat sheet here of kind of where all my angles are, you can see that we're going to fall here in quadrant 2. So this is something that you should hopefully be pretty familiar with at this point. Okay, so I've got my initial side, I'm going to go this way, so I've got somewhere in here, and then here's where my reference angle is. So this is what I need. This is the reference angle that I am trying to figure out. So notice now that we are getting close to this axis here. So to figure that out, I'm going to take 180 degrees minus 102 degrees. And so my reference angle in this case would be 78 degrees. Now I'm going to show you what to do with that in a few minutes, but I want to keep talking for a little bit. So for notation, we use this theta prime to indicate that we have a reference angle. And then I just wanted to give you a really quick cheat sheet of like, what subtraction do you do? So if you're in quadrant 1, you can just use theta, of course. You don't have to do this if you're between 0 and 90 degrees. When you're in quadrant 2, you want to take 180 degrees minus whatever theta you've got, and that'll get you to your reference angle. When you're in quadrant 3, then what you're going to want to do is you actually want to reverse this calculation. So your right triangle is going to use this axis still, but you want it to end up, you need it to be a positive reference angle. So to do that, we do theta minus 180. So just notice how these two things are flip-flopped. And then finally, for quadrant 4, you'll take 360 degrees minus theta if that's where your reference angle ends in. Now, in my previous video, we talked about the special angles of 30 degrees, 45 degrees, and 60 degrees. So we did all the work to kind of fill in this chart, and I've been doing this throughout my video series so far. And so you want to leverage this info whenever possible. In fact, in my other video, I brought up that you definitely want to have this memorized. Your life is going to be so much easier if you have this memorized. The earlier you memorize this, the better your life is going to be. I can't stress that enough. Okay, so what I want to do is I want to use this chart. And now I want to talk about how to use reference angles with trig functions, and we're going to leverage that chart. So I want to find the values of all 6 trig functions for 240 degrees, and you know what I'm going to say, draw a reference. So I highly recommend that you pause the video here, draw your reference, and then when you think you've got that, hit play when you're ready. Okay, so here's my reference. I'm going to end up somewhere in quadrant 3. All right, so I've got my little right triangle here. And from here, we can come up with the reference angle. So that's going to be 240 degrees minus 180 degrees. So my theta prime in this case is 60 degrees. And so there's our reference angle. So we're going to be using that chart I just showed you to help us figure out our trig function values. It's really done a lot of the work for us. We've already discussed this. But there is one thing we have to be worried about. We are in quadrant 3 here. So even though we have this reference angle, we do have to keep in mind, what are the signs of our trig functions? And so in another video, I discussed the little device, all students take calculus. So what this meant was all, so this is in the first quadrant, all trig functions are positive. Students had to do with the second quadrant. Take had to do with the third quadrant, calculus had to do with the fourth quadrant. I will put a link to the video where I explain all of this, but we are specifically interested in 60 degrees, but we're talking about that we're actually in the third quadrant. So in the third quadrant, only tangent is positive and cotangent. All the rest of the trig functions are negative. So this is very important that you kind of remember this, because now it's going to kind of come into play here. So tangent and cotangent are the only positive functions. So when I use this chart, now I have to be careful, right? This I can definitely use, so I've got my reference angle here of 60 degrees, but I have to use the little caveat now that these two values here, these are going to be positive, while the rest are going to be negative. So you have to make those adjustments on your end. Okay, so with that being said, so for sine of 240 degrees, so both sine and cosecant, they are reciprocals of one another. So I went ahead and just put them both down. So the sine of 60 degrees is square root of 3 over 2, and then the cosecant is 2 square root of 3 over 2, but these both need to be negative. So notice I made both of them negative, right? And then cosine, so for cosine, these also need to be negative. So cosine of 60 degrees I know is 1/2, but I have to adjust this now for being in the third quadrant. So this is negative 1/2, not just 1/2. And then, we just take the reciprocal for the other one. Okay. And then finally, tangent and cotangent were the only ones we said were positive. And so these are going to have the values of square root of 3 and square root of 3 over 3. So I can't emphasize enough. This is so important, or otherwise you are really going to spend a lot of time working on this. So, all right, that's all of our values. And one other thing I want to point out, notice I've written 240 degrees. That is what we are actually trying to figure out here. So even though I'm using this reference angle here, just be careful to not write it in your trig functions. There's kind of a lot here that you have to keep track of. This is not necessarily the simplest thing. There's a lot of details that we've got at this point. All right, so now I want to just talk about how to find any non-quadrantal angle in 4 steps. So step 1, if your angle is either greater than 360 degrees or if it's less than 0, then find the coterminal angle by either adding or subtracting 360 to obtain an angle somewhere between 0 degrees and 360. Second, you want to find the reference angle, which we've been spending a lot of time doing in this video. 3, determine the trig values for that reference angle, theta prime, and then double check the signs when you're done. Remember, all students take calculus. That is probably like the way I would remember this even now if I got thrown off. All right. Now, you can also avoid errors by sketching the angle in standard position. So here's the thing with sketching. It doesn't have to be perfect. It just helps your brain. I think a lot of times students really struggle with trig because they don't make the pictures. But trig really requires the sketching. And so what you really want to just remind yourself, these sketches are literally just that, something quick just to make sure that you understand where you're at to orientate yourself. All right, so now what I want to do is I just want to go through a few more examples. So let's talk about evaluating specific trig functions. So let's start with the sine of negative 150 degrees. So I want to draw this. So as it stands, we can technically graph this. I know we're supposed to find the coterminal angle. I do want to just take a second to talk about like how could you graph something like this just to make sure that you remember. So I showed you this reference picture earlier, right? So these are the angle measures as we go around this way. Well, I can reverse this picture to go in the negative direction. So notice now I'm going from 0 to negative 90. This would be negative 90 to negative 180. So you literally just reverse the picture if you want to go in the opposite direction. And so since we're talking about negative 150 degrees, we're talking about being somewhere in this quadrant. Okay, so if I wanted to sketch that out, so I'd have my, my initial side, and then I'd go this way, and so I have my terminal side here. And so I can create this reference angle. Okay, so before I go too far, I want to just convince myself of this, okay? So let's find an angle that is coterminal just to see if we can really believe this. So I've got negative 150 degrees. I'm going to add 360 to it, and I get 210. So if I add 210, that would indeed get us in the third quadrant, right? So we can feel pretty good about this. Okay, so that's cool. This is 210 degrees. We're all good there. Next, we've got to find the reference angle, which I know now just by looking at this, the way that I'm going to find the reference angle is I'm going to take 210. That's the way that we want to look at this. And now find that reference angle of 30 degrees. Okay, so at this point, you're probably noticing like there are times where I care about the signs and times where I don't. So the angle that's coterminal, that's going to have the exact same signs. You don't have to worry about like, oh, negative 150 or 210, or do I have to change the signs for that? You don't. It's when you get to the reference angle that you have to worry about the signs, okay? So we want to use this theta prime of 30 degrees, but then we have to adjust it for being in the third quadrant. You see what I'm saying? Okay, so let's go ahead and do that. So I've got, let's see, here's my 30 degrees. So for cosine of sine of 30 degrees, so that's 1/2. However, we are in the third quadrant. So in the third quadrant, only tangent and cotangent are positive. So I need to adjust this to be negative. You see what I'm saying? Okay, so this is going to equal negative 1/2. That would be the value. Okay, so now let's pivot to the next one, cosine of negative 510 degrees. So you know me, I always say math is not a spectator sport. I highly recommend that you just pause for a moment, try to find the angle that is coterminal with this, and then see if you can finish this one entirely. Hit play when you're ready. All right, so I first want to find that coterminal angle, so I take negative 510 degrees plus 360 times 2, and I get 210. All right, so you'll notice then that we are talking about the same situation that we had here, right? So same reference angle, so I actually don't have to worry about that. But what I do have to worry about is still the signs, right? So cosine of negative 510, or, so I'm using cosine of 30 degrees. So if I come back here, so cosine of 30 degrees, we've got square root of 3/2. This is the value that we're interested in. But is this going to be positive or negative? It's going to be negative because only tangent and cotangent are positive in that quadrant. So this one's going to equal negative 3/2, or square root of 3/2. Okay, and so now I want to pivot to something kind of similar, but like evaluating expressions like this. So now I've got sine squared of 120 degrees plus cosine squared of 120 degrees. Okay, so the first thing I just want to remind you is that, remember, when they're squared, we actually want to just find the value of this and then square that value later. So that's the way we want to think about that. All right, so naturally I've got to get my reference angles. So here is where my reference angle is. All right, so challenge to you, I would recommend that you pause here and try to find sine of 120 and cosine of 120 to check your understanding. Hit play when you're ready. All right, so here is my reference, and so to get to what my actual reference angle is, I'm going to take 180 minus this 120 degrees to get 60 degrees. So here is what I need to be concerned with. Okay, and so remember, we're talking sine and cosine. So is sine positive or negative, and is cosine positive or negative? That's what I want you to think about as we move into this next part. All right, so we're talking about looking at 60 degrees. So I'm looking at these two measures here, right? However, sine in the second quadrant is positive, and cosine will be negative. So positive, negative. I'm going to note those, all right? So let's summarize those. Sine of 120 degrees is square root of 3/2. Cosine of 120 degrees will come out to negative 1/2. Cool. And so now I can just square these results as I needed to up here. Alrighty. So I've got square root of 3/2 squared and negative 1/2 squared. So it didn't really matter if we knew if it was negative or not, but I did want to be precise with this. Okay, so if I go through all this, I get, of course, 3/4 plus 1/4. That's just going to give me 4/4, which is equal to 1. And so that is our answer. Okay. So I'm going to just talk about a few other things in this video, but I do have more examples of those previous two sets of examples available. So I've got a video where I take a look at like finding all 6 trig functions for different angle measures and then more expressions like that. I'll drop a link to that in the description if you want to see more like that. Okay, so just continuing on here. So a couple other exercises that can come up. So find all values of theta if theta is in the interval from 0 to 360 and has the function value cosine of theta equals square root of 3/2. Okay, so you probably know what I'm interested in first is I want to note that this is positive, so where can this be positive? Which quadrants? This is only positive in either quadrants 1 or 4. And because this is positive in 2 different quadrants, that means we have 2 different values that we are looking for theta, all right? Okay, so I have quadrant 1 here and quadrant 4 somewhere in here. So let's start with the easier one, so finding this value in quadrant 1. Well, if cosine of theta equals square root of 3/2, this sounds awfully familiar from this chart that we have been working with, right? So cosine of theta equals square root of 3/2 right here. That is here at 30 degrees, so I can leverage that. So this angle here is 30 degrees, but then how do I figure out this one here? Well, I know that the reference angle is 30, so what I can do is I can actually just take 360 minus 30 degrees. So I can kind of reverse engineer that process I had from earlier. So this will give me 330 degrees, and so that would be this reference angle. And so those would be the 2 values of theta that would work in this case. Now, if you want to see more examples of that, I do have another example video on just that. And then the last thing I want to talk about are things like true or false statements and having to prove them. So I've got cosine of 60 degrees equals 2 cosine of 30 degrees. So is it true or false? So you need to actually prove these and know why. You don't want to just make the guess of, I think it looks true, that looks good to me. No, don't do that. So we've got 60 degrees and 30 degrees. That's what I'm interested in. So cosine of 30 degrees, cosine of 60 degrees. I want this value, I want this value. So I'm going to take both of these and I'm actually going to plug them now into the expression. So cosine of 60 degrees we said is 1/2, and cosine of 30 degrees is square root of 3 over 2. So if I plug that into this, I get 2 times the square root of 3 over 2. You can tell just by looking at this, right? Definitely not equal, proves it's false. And so that's the level of reasoning that you want to use. All right. Whew. It was a lot that we talked about in this video. So if that was helpful, consider leaving a like, a comment, sharing it with a friend, or subscribing to the channel. Like I said, I always say I'm trying to provide free quality math help for all. And so otherwise, guys, that is it for this one. Perhaps I will catch you in some of the example videos.